Welcome to the final stop on our tour of the Krafla volcano. We hope you've had a lovely time. Now, we'd like to teach you about a very important feature of the volcanic system, fissure zones. Fissure zones are a feature that is seen a lot in the Krafla volcanic area. Fissures are vents that have opened up as the divergent plate boundary stretches apart, leaving gaps in the rock. These openings allow for lava and magma to flow through them. Often slowly and with a high viscosity, but lava does shoot up on occasion. Fissures are mostly found along rift zones, such as along the Mid-Atlantic Ridge here in Iceland. As the Eurasian and the North American plates slide apart, the rock opens and fissures can form, along with lava channels. When magma intrudes the fracture to form dikes, fissure swarms may occur. The vents can be anywhere from a few meters to a few kilometers long. As was the case during the Krafla fires of 1975 to 1984, which you learned about earlier on this tour, these vents can cause large flood basalts, which run in lava channels and lava tubes. The main rock types found in Krafla are basalt, rhyolite, andesite, and dacite, and the explosions were mostly mafic, specifically basaltic. To form a fissure, the dikes are usually fed by a magma reservoir, such as those found near volcano centers. So where exactly do we see fissures in the Krafla region? During rifts in the past, eruptions on the fissure swarm occurred within 7 kilometers of the central volcano of Krafla. However, faulting occurred up to 70 kilometers away. Holocene eruption fissures are common closer to central volcanoes. In the south, eruption fissures are found further away from the central volcano than in the north of Krafla. This is likely either due to a large magma source in the south that is feeding the fissures in that area, or it is caused by the Husavik transform faults transferring from the plate extension in the north. The Husavik fault is part of the Giornes fracture zone, there's no way I pronounced that right by the way, which accommodates movement between the northern volcanic zone and the Kloblensky Ridge. Most of the fractures around the caldera are parallel to the fissure swarm. The density of the fractures within lava flow fields increases with field age. This suggests that repeated rifting events have occurred in the fissure swarm in the last 10,000 years. The length of the discontinuous volcanic fissure at Krafla is 11 kilometers, with lava flows covering a 74-kilometer area. The volcano is shield-shaped and 25 kilometers wide, with the caldera in the middle. The caldera was formed from the eruption of rhyolitic welded tuff in an eruption that occurred 100,000 years ago, collapsing the volcano and leaving the crater.
The Krafla fissure swarms take up around 60 to 70 kilometers in distance from north to south around in the northern volcanic zone. Keep in mind, the northern volcanic zone is the volcanic region of northeast of Iceland. Interesting enough, the Krafla fissure swarms contain both eruptive and non-eruptive fissures. However, there are no specific areas where the eruptive fissures are placed, since there is an uneven distribution along the designated area. However, there are more eruptive fissures found in the southern end, approximately 10 to 30 kilometers south of the central Krafla volcano, in the Krafla fissure swarms compared to the northern side. Regardless to why there is an interesting placement and pattern of the fissure swarms in Krafla. How is it originally formed, and how do fissures cause eruptions? Since we have mentioned before that Iceland sits in a divergent plate boundary, when two plates move away from each other, this activates intense fracturing of fissure swarms along with the intrusion of magma, which form dikes that can lead to eruptions. The faults and fractures of the fissures were formed by rifting episodes. In detail, the magma made intrusions, which we call rifting event, through fractures that would form dikes constantly for an extended period of time. This caused fissure eruptions. Rifting episodes do not occur often in the Krafla volcanic zone. However, since the settlement of Iceland, there had been 2 rifting episodes. one being in 1724 to 1729, called the Mivatin rifting episode, and the second, which had been scientifically recorded, was in 1975 to 1984, called the Krafla rifting episode. Both episodes had very strong seismic activity and change in fault position, which have occurred in the fissure swarms, leading to fissure eruptions. Nevertheless, you may ask why they are called episodes and why they have occurred for an extended amount of years. Fun fact, these episodes are called the Krafla fires due to its giving a sense of doom. It initiates with a growing seismic activity within their first year of the episode, which then ends to a sudden strong earthquake, formation of fissures, and small lava eruptions. However, it then gets quiet, where shifts to slight gravity changes and crustal separation occurs. Then back again. The magma comes up from the central volcano, where it transports to the magma chambers. Remember, the magma chambers are not deep underground. This allows magma to intrude into the fissure swarms that then inject into dikes that eventually, in the end, lead to lava outflow, therefore calling it the Krafla fires. The fissure zone and the Krafla volcanic zone itself have evidence of a variety type of rock. There is a large evidence of rock compositions of olivine tholite, rhyolite, hyaloclastite, and more. Krafla contains basaltic magma. Hint to the previous quiz question. One most common rock in the fissure zone is the rhyolite. The, Hrafninuhrigur is one of the places around the fissure zone that contains a rhyolitic fissure eruption beneath thin ice. However, to not leave you out on what rhyolites are, we will discuss that next. Rhyolite is an extrusive igneous rock, which had been formed by magma rich in silica. Hint to the next quiz question. The rock is extracted from the volcanic vent, which then cools quickly, due to its low contact of mafic minerals and have very fine-grained surface. The way in which rhyolite magmas are produced is by igneous differentiation of mafic magma through fractional crystallization, or it can be the assimilation of melted crystal rock. You can see the image on the left below. It has the composition of quartz, K-feldspar, and biotite. In the Krafla zone, there are two phases of rhyolite volcanism formation. The first one being the formation of the caldera, while the second is the relation of the emplacement of a ring dike. However, even though rhyolite is the most common rock found within the Krafla volcanic zone, the fissure swarms specifically do not erupt as much rhyolite.
Thank you for joining us in exploring the magnificent Krafla volcano. This is just one of the many interesting geological sites in the beautiful island nation of Iceland. The country's position right on top of the mid-Atlantic ridge leads us to many tectonic creations. We hope you've enjoyed learning about Krafla, as well as the lava fields, calderas, and mountains in the area. You've also learned about the Krafla power plant and the effects of tectonic activity on its functions. The Viti, aka Hell, caldera, and its bright blue waters, as well as the lava fields and the ropes that they've left behind. Thanks for listening, and we hope you'll visit majestic Iceland in person if you get the opportunity.